Parameters of a probability distribution. Remember that with a probability distribution, we have a description of a population instead of a sample. So the values of the mean, standard deviation, and variance are parameters, not statistics. Now, the mean, variance, and standard deviation of a discrete probability distribution can be found with the following formulas. Now, for the mean, for the probability distribution, we have mu, which is equal to the sum of the quantity of the data value x times its probability of that variable x. Now, for the variance, which is sigma squared for a probability distribution, the variance is equal to the sum of the quantity of the data value minus the population mean squared times the probability of that data value. This format is just a little bit easier to understand. Now, for the other variance for the probability distribution, we have the variance, which is equal to the sum of the data value squared times the probability of that data value minus the population mean squared. Now, this format is easier for manual calculations. Then we have the standard deviation for a probability distribution, which is sigma. Sigma is taking the square root of the variance, so it would be the square root of the sum of the data value squared times the probability of the data value minus the population mean squared. Now, we also have the round off values for the population mean, the population standard deviation, and the population variance. Now, you round results by carrying one more decimal place than the number of decimal places used for the random variable x. If the values of x are integers, then you're going to round the population mean, the population standard deviation, and the population variance to one decimal place. Now, exceptions to the round-off rule. In some special cases, the above round-off rule results in values that are misleading or inappropriate. For example, with 4 engine jets, the mean number of jet engines working successfully throughout a flight is 3.999714286, which becomes 4.0 when rounded to one more decimal place than the original data. Now here, 4.0 would be misleading because it suggests that all jet engines always work successfully. We need more precision to correctly reflect the true mean, such as the precision in the number 3.9997114.